There we go. All right, Advent of Code 2023, day 19. Aplenty. The elves of Gear Island are thankful for your help and send you on your way. They even have a hang glider that someone stole from Desert Island. Did we really steal it? Since you're already going in that direction. It would help them a lot if you would use it to get down there and return it to them. All right, as you reach the bottom of the relentless avalanche of machine parts, you discover that they're already forming a formidable heap. Don't worry though, a group of elves is already here organizing the parts, as they have a system. To start, each part is rated in each of 4 categories: extremely cool looking, musical, aerodynamic, and shiny. Conveniently spelling out Xmas. Then each part is sent through a series of workflows that will ultimately accept or reject the part. Each workflow has a name and consists of a list of rules. Each rule specifies a condition and where to send the part if the condition is true. The first rule that matches the part being considered is applied immediately, and the part moves on to the destination described by the rule. The last rule in each workflow has no condition and always applies if reached. Okay. Consider the workflow. Whoa. Okay. Gotta parse this with my eyes here. This workflow is named EX. Okay, I see it. It contains 4 rules. All right, so it's comma separated. If workflow EX were considering a specific part, it would perform the following steps in order. Rule X greater than 10 colon 1. If the part's X is more than 10, send the part to the workflow named 1. Otherwise, if the part's M is less than 20, and then the final rule is A. Oh, I see. Rejected is R. So A greater than 30, reject the part, but only if it hasn't passed these 2. And then once you reach the end, you accept the part. Okay. If a part is sent to another workflow, it immediately switches to the start of that workflow instead and never returns. If the part is accepted, sent to A, or rejected, sent to R, the part immediately stops any further processing. Okay. The system works, but it's not keeping up with the torrent of weird metal shapes. The elves ask if you can help sort a few parts and give you the list of workflows and some part ratings, your puzzle input. For example, this. Okay. Do we just start at the top and work down? The workflows are listed first, followed by a blank line, and then the ratings of the parts the elves would like you to sort. All parts begin in the workflow named in. Oh, okay. So it's an in right here. Oh, I see. So this says if the S value is less than 1351, go to PX. Otherwise, go to QQZ. And then this says if S is greater than 2770, go to QS. Or if M is less than 1801, go to HGJ. And if neither of those conditions is true, then reject the part. That's the way I'm reading that. The 5 listed parts go through the following workflows. Okay, so we can use this test input to verify all that in our code. Ultimately, 3 parts are accepted. Adding up the X, M, A, and S ratings for each of the accepted parts gives us 7540. Okay, whatever. And it all adds up to 114. Okay. Sort through all the parts you've been given. What do you get if you add together all of the rating numbers for all of the parts that ultimately get accepted? All right, so this is going to be mostly a parsing problem, at least for part 1. Get input 2023, day 19. Mohad said, I just finished part 1 of today's problem, still thinking about part 2. Okay. Sounds like it's going to be exciting. 716 lines of data. So these are all the workflows, and I assume there's one called in. There it is. So that's where we start. And then we have parts. Where are the parts? Parts is parts. All these parts. Okay. So we got a bunch of each. AKA command. Thank you for the follow. Welcome. All right. Yeah, and let's go. This is the test input. And then let's just use our usual routine. Create 19 here. create 19 here. Oops. I'm just trying to jump around and I'm failing miserably. 19, and then day 19. Come on. And then up here we go and create this thing, go to it. Did I go too fast? There we go. 2319. 2319 is the, I don't know if anybody's ever seen Monsters Incorporated, but that's the code that gets yelled out whenever there's a human on the scare floor. I don't know why that's stuck in my head. Analyze code, good morning. Oh, Code Muck, I missed you. Good morning, how are you? And Analyze Code, thank you for the follow. Welcome. All right, with this done, Demi Godcat, thank you for the follow. Parsing seems to be a little awkward because we've got to split these things up. Determining whether or not we have a workflow or a part is easy, right? We can just look to see for the first character. If the first character is a open brace, then it's a part. Let's define a workflow. Actually, let's define rules, and then a workflow will be a hash map. That way I can just say QQZ, for example, and I could just look it up in the hash map and get a list of rules. So let's define a rule. And a rule is going to be a condition with a condition and a action with an action. Right? So the action is going to be accept, reject, or go to something. And the condition is going to be the value, the variable we're comparing against, the direction we're comparing, greater than or less than. That's the only two options, right? Greater than, less than. That's all I see. There's no equals to or less than or equal to, or yeah. He doesn't actually list out the different conditions, does he? He just has them in the example. That's fine. We'll just assume everything's greater than or less than. Actually, we don't have to assume. We can just say grep equals in input 2023-19. Oh. Yeah, except I only wanted to grep the workflow part of that. Thank you, grep. Yeah, okay, so there's no equal sign in any workflow. All right, so the action, well, the condition is going to be, how do we want to store this? I can ignore the letters, right? I could just make this an array of 4 usizes. Right? I can just say, I can put this here, type part equals usize 4, right? And that way we can store in here, we say less than, it could be usize, and then the value that we're going to compare against, greater than, those are the only 2 conditions. Oh no, there's a third condition here. I guess always true, right? That's going to be one of the things. And then in actions is going to be what to do. We can accept, we can reject, and we can go to, CodeMonk says there's only less than or greater than. Thanks. Yeah, no, that's good info. It should have been part of the puzzle, right? Go to string. Part of the puzzle description, I mean. I think that's it, right? These are the rules, and we have these parts. So now we just need to figure out how to parse everything. We can say, well, first let lines equals, here's the lib. Read lines, test input. And then for line in lines, we're going to look at the first character. If line dot starts with open brace, then it's a part. Otherwise, we're going to parse workflow. Oops, like that. So parsing a part is just, I guess we can split on commas after we strip off the front and back. Let line equals line dot strip suffix close brace unwrap, and then strip prefix that, and then we can say, oh yeah, we need to store the parts. Parts is just going to be a vector of part, a comma, and then workflows is going to be a hash map from string to vector of rules, rule. And we just need to pull in hash map. Right? There we go. And now line, we just split it apart by commas, remove the XMAS. I assume they're all going to be in order, but we can verify that. Let ch comma num equals line split once on equal. Oh no, I forgot the comma part first. For part in line split comma, we get the numbers. Oops, split. So this should be the character. Oh, unwrap. That should be the character, and this should be a parsable number here. We can say match ch. If it's x, we're going to say, oh, we need to create a new part. Let's call it section. Second section. Let part equals 0, 4. Right? And then we can just push that on. So it's part 0 equals num parse unwrap, comma, and then we do the rest for XMAS. Just in case they scramble the order, we can do that way, and anything else is a reject. Line. Okay, that should be part, and then once we're done with that, we can say self parts push part. This is still a little louder. The Funny Whip, thank you for the follow. Welcome. Oh, these are strings. Okay. Oops. Come on. There we go. So now we have parts, hopefully. We can print those out. Oh, I gotta DD these guys. Can you derive debug on a type alias? Nope. That's okay. I think that means it'll work if I try to print it. Like this. Self parts. Analyze code. Can you tell me how you did a fast way to change a single character to a double character? Yeah, just 1 second. Let me just get this. Oh, this is all good. Yeah, so in VI, I'm using Vim, right? And in Vim, if you type the letter R, it means replace the character under the cursor with whatever you type next. So if I hit 8 now, it changes it to an 8. So all I did here was I hit R quote. And then because that's now the last command I did, the dot will do it again. So I can just hit dot and it'll do it again, right? So I did the first one, and then I just hit dot for the rest of them and just used the cursor movement to move the cursor around, J and K to move around. This looks correct, right? Yeah, this all looks good. I don't have, I mean, it's kind of off the screen there, but 1013, yeah. Okay, so we have the parts. Now we just have to do the hard part, is parsing the workflows. So it's going to split here. I don't know why I had to put it in curly braces, but there you go. So we're going to split once on that. Let name, comma, rule set equals line split once on that. Right? And then so that means the rule set's going to have this, but also include that thing at the end there. So we'll just save name for later. So the rule set, we're going to say let rule set equals rule set strip suffix this unwrap. And now we should have a comma separated list of rules. Let mut rules equal. Yeah, that's all. It's just a vec of rule. Okay. Let's do that. Let's say vec rule equals vec new. And then let's write a little from stir for the rule. So we can just say for rule in rule set rules.push rule.parse unwrap. Right? And then we're going to say self workflows insert name to string rules. And that should be all the rules. Oh, rule set is the, oh right, I have to separate it by commas. And now we don't have from stir. Can I do that with an action? No, I can't. So I'll just have to add it manually. For rule, here it is. Impl from stir for rule. There we go. Implement missing members, string. All right, so to parse a rule, it's going to be just this bit here. It's going to be, it could be just A, could be just R, or it could be some stuff like this. Greg CD, thank you for the follow. Welcome. So, okay, we can have separate, actions. Yeah, let's do that. So let's make a little from stir for action. Right? And that way we can just create a new action. We can just parse a new action easily. So we can say match S. Action is going to be one of these guys, right? So it's just A goes to OK self accept. R goes to OK self reject. And anything else goes to OK self go to S2 string. How's that? Why did that not? Oh, because I forgot to close the OK. There we go. So now here what we can do in the rule, we can see, is there a colon in the rule? And if there's a colon in the rule, then it's going to have a condition and followed by what to do. If there's no colon in the rule, then it's just going to be an action directly. So we can say if let sum cond act equals s.split once on colon, else it's just going to be an action, and what we can do is say okay self oops, the condition is going to be condition true, right? And then the action is going to be whatever the action is from S. So S dot parse unwrap, right? Right. If there's no condition part of it, then it's true. And that way we'll always do whatever the action says to do, which is going to be one of these guys. Okay, I think I'm understanding myself. Otherwise, we're going to have a condition and an action to perform. So we can just write a from stir for a condition, right? So the condition is either going to have a less than or a greater than, and then it's going to have a number. It's always, so the number is always going to start at the, okay, so let value equals S of 2 dot dot parse unwrap. Right, and this will give us the value side. Then we have to look at, and the problem is this is a stir. I can't just say S of 1. But I think I can, as bytes of 0, and then it's going to be X something. Yeah, so this is going to be the index. And then this is just M, A, and S for 1, 2, and 3. The Road, thank you for the follow. Welcome. Return error, format bang, invalid, condition S. Right? So it gives us the index that we're going to be setting the value to, and now we just need to know if we're doing a greater than or less than. So we can do another match. Match S as bytes 1. If it's less than, then this becomes OK of self less than index and value, and otherwise it's greater than you can do S1 dot dot equals 1. Maybe let me try that. And as Scoop says, match S dot dot 1, and then the match is X in double quotes. Okay, well, let's try it. Anything else here is an error. Invalid condition. Oh, these all have to be byte literals, and there's an error up here as well. Oh, because I never finished it. Okay. Let's see if this changes things. If I say S dot dot 1, we'll look for, yeah, expected stir found char, right? So I can do this again. Oh, expected stir found stir. Okay, so, right, we do the ampersand in front of it. Okay, and then we can do the same thing over here. So this can be S of 1 dot dot 2. And then we change these to quotes. All right, and now we just need to write this part. Yeah, this saves the double call to as bytes, right? So now we just need to say, okay, self, condition, con to parse unwrap, action, act parse unwrap. Oh, look at that. It worked. Well, it compiled. Let's see if it prints out. workflows. Oh, wow. Isn't that sweet? PX. So 2, so XMA, A is 2, is less than 2006. Then we go to QKQ. Otherwise, if M is greater than 2090, we accept it. Otherwise, we always, condition true, go to RFG. Nice. Okay, I think we have that. Let me look for HDJ. Just make sure that's in there. Here's HDJ. That's the wrong side of it. Here it is. Yeah, this is HDJ. That's the last one in the list. Just want to make sure it was in there. All right, if M is greater than 838, accept it. Otherwise, always go to PV. Perfect. All right, I think we have the rules parsing. I'm gonna commit this because this is a lot of work, and I'll probably break it partway through part 1. Right? Git status, git add source, git commit dash M 2023 day 19 parsing. The Road says, I'm learning Rust. Do you code on Twitch using Rust? Yes. Yes, I exclusively stream Rust coding streams. I haven't gotten into Rust, the video game, yet. Because I suck at video games. All right. So now I think we just need, for each part, this is going to be part 1, right? For each part, we're going to go through and just walk our way through all of the rules. The Road says, nice. Thank you. For part in self parts, we're going to start with our workflow called in. So let mut current workflow is equal to in. I'm going to stringify that because I made everything else strings. So to avoid the lifetime stuff. So we're going to grab the workflow. I guess we just loop, right? Until we find an accept or reject. Let workflow is equal to self workflows get current workflow unwrap. And then we're going to see what the rules are. We're going to apply each rule in turn, right? So we can just say for rule in, right? And this gives us rules. Oh, this needs to be ampersanded. Yeah. All right, so now we just need to match. Oh. Iter? Unwrap iter? I was hoping that would just automatically do that. Okay, there we go. Now we have a rule. Sweet Radish says, only done P1, Rangers strike again. Code Monk says, shh, no spoilers. Yeah, no spoilers, please, for part 2. We'll see what happens when we get there. Let's see. So we have rule. Now it's a condition. We have to match the condition. So match rule, not condition. And we figure out what action to take, right? So if it's less than, if the variable in this spot is less than this value, then we're going to apply the action. So I guess we can say let action equal. Oh, wait. Yeah, I was trying to see how can we keep this simple. Let's go through this one here and see what happens. If part var is less than val, then we want to perform the action that we have, right? The rules action. Oh, so let's just make this a pass equals. And we can just make this a true or false statement here, right? And we can say part var is greater than val, and true is just true, right? So now we can say if we passed the condition, we can apply the action. That way we only have to write the action handling in one spot. So we pass this action, we now going to do the thing that it's asking us to do. So we're going to say match rule. Oh, why is this wrong? Rule is unknown. Oh, because I was in the middle of editing. Okay. If pass, then we're going to say match rule action. Okay. And if it's an accept, if it's an accept, then we're going to add in the part numbers, right? Yeah. Okay. So it means we need a total. So we can say total plus equals part iter sum. Right? If it's reject, then we don't do anything. Oh no, if it's a reject, we want to continue at the next part because this part's been rejected. And next part. If it's go to, we're going to go to a new workflow. So we're going to say cur wf equals wf, and then continue next workflow. Right? Because we don't want to keep processing the rules. And this is next workflow. Right? And then hopefully this exits at some point. And then we can just say AOC lib output total. Bam, that blew up. Oh, because of that. Oh, I forgot to put these things in here. And we can't specify, even though we know, okay, I'm not gonna fight that battle again. Borrow? Sure. Why do we have to toString a string? Oh, because it's a reference. Okay. Ooh. Computing. Okay, but we have an infinite loop because it's not done computing. Reject continue next part. Go to next workflow. Oh, if we, at some point the last rule has to apply, right? Oh, here. If it passes, we have to stop, right? So if we accept it, then it's got to go to the next part. So let's move this down here. Oh, inside the pass. If it passes, then we're going to say continue next part. The reject won't do anything. And then that way the accept and reject will fall down to here, and the go to will automatically just pop to the next workflow. Okay, let's try that. Yeah, that was the bug. So 19.114, I think that was it, right? Yes, 19.114. Okay, so let's use the real input and stop printing out our workflows. Test input 2023-19.text 575412. Let's see what we get. Yay, that's the right answer. Okay. Clippy? Clippy's good. All right, this was mostly a parsing problem. This was pretty straightforward from the point of view of handling all the actions and whatnot. I think I spent more time parsing than I did solving. Okay. Git status, git commit -am 23 day 19 part 1. Codebunk says that's correct. Very nice. Thank you. Yeah, a lot of parsing to set up the problem today. Yep. Yeah, I agree. All right, so let's see part 2. Dive right in. Even with your help, the sorting process still isn't fast enough. I don't know, that was less than a millisecond. One of the elves comes up with a new plan. Rather than sort parts individually through all of these workflows, maybe you can figure out in advance which combinations of ratings will be accepted or rejected. Oh. Each of the 4 ratings can have an integer value ranging from a minimum of 1 to a maximum of 4,000 of all possible distinct combinations of ratings. Your job is to figure out which ones will be accepted. Alan, thank you for the follow. In the above example, there are this many distinct combinations of ratings that will be accepted. So obviously we're not going to enumerate all of them, right? We're going to have to come up with a clever way of processing this. 167 trillion is what I'm seeing out of this thing here. Right? This is thousands, millions. Yeah, 167 trillion. Consider only your list of workflows. Those to part ratings that the L's wanted you to sort is no longer relevant. How many distinct combinations of ratings will be accepted by the L's workflows? All right. I mean, I think I know what I have to do. It's just figuring out how to make that into code, right? Because this, for example, let's take a look at the very first problem here. This will accept, 4,000 times 4,000 times 4,000 times whatever 4,000 minus 1351 is. Parts. Filtered through QQZ. So you have to figure out how many combinations QQZ can accept, right? And that can accept, this many as one possibility, and this many as another possibility, or none as a third possibility. So you have to sum how many are here plus how many are here. And HGJ, where's that? Has its own set that are accepted, and then it goes to PV, and then PV goes to here. So I can see why this number, even for the small input, this number is in the trillions. Because you multiply all of the ones that you can get from this, and then you add in all your remaining ones. Yeah, Mr. says 4,000 to the fourth. Yeah, so you start out with 4,000 to the fourth as a possibility. You go to in, and you trim it by this. Right? So you say, okay, it's 4,000 to the fourth minus this many, plus whatever PX gives you, and then add in whatever QQZ gives you, right? Do I even know how to do this? 23, 19, there we go. So we're going to start with in, as we do. I'm going to grab that work. I'm just going to do one, and then we'll figure out how to loop it after that. So we're going to get the workflow, self workflows, get cur wf unwrap, and then I'm going to go through each rule and calculate how many there are in that rule. And then add in whatever that rule gives us. So it might be good to make like this recursive function. Scoop says when you get to PX, you're already limited to S is less than 13. Right. So it's this plus then you have to pass in to PX how many pass through your first filter. QQZ doesn't get any filter because it's just accepted automatically, right? So you have to look at each of the, so each one only has one, right? There's no rule that has a combination of like A is less than 2006 and M is less than 5004 or whatever. Not 5004, but you know what I mean. It only restricts one range each time. Right. So here's what I see what you're saying, Scoops, but I think I'm agreeing with you. What I'm thinking is we start with four ranges, that look like this. Right? And then if, this is X, M, A, and S, right? And so if we look at this first rule, we now create a new array of work that says 1350, right, for S. And then we pass this into PX. And what does PX say? px says a has to be less than 2006. So that's going to change this to 2005, right? So now we have this restriction here. So now we've reduced the total number of possibilities. And for that, we pass that to QKQ, right? And QKQ says what? X has to be less than 1416. Right, so we further reduce. Oh, I did the wrong thing. On PX, it should have been A. Right, this is 2005. And now X is, QKQ is 1416, so 1415. And that gets accepted. So now we add into the total, the number that are here, times this, times this, times this, right? And if we have a greater than, which I guess I didn't step through a greater than, right? But the greater than would just increase the bottom range. And then if we hit an A, we multiply them all together, or multiply the deltas all together and add that to the total. For QQZ, well, we start off at the beginning again, and then we say S is not less than 1351, so it must be 1351 or bigger. So here's 1351, right? And it gets passed to QQZ, right? And then what does QQZ do? It has two different options, one for QS, three options, one for HEJ and one for rejection. So we have to do the same thing, right? For each level. Scoop says, nice. Yeah, it's nice to write it out like this, but actually implementing this is going to be really painful. So for the first QQ, I'm just going to do this one by hand here again. QQZ, we start off with this guy. S is greater than 2770. So we change this again, right? And then pass that to QS. We also have one at the same level where it's less than, so this goes back to 1351, and it has to be 2770 like that on the S, and then let M has to be less than 1801. So 1800, and that gets passed to HDJ, right? And then there's the third possibility, which just gets rejected, right? And then we have to go through QS with the same restrictions and HDJ with the same restrictions. Goldmonk says, yeah, it took me a while to realize that last detail to adjust the ranges accordingly. Yeah. Tycho13, thank you for the follow. So how the heck do I implement this? I don't know how to do this. Well, let's start off with the basic. Yeah, I think this would be best done recursively, right? We'll call each one recursively and do the restrictions on each one. Wizard says 1 to 4,000 inclusive. Yes, inclusive, right? So we just subtract and add 1, right? Does our range, so Rust has a range type. What functions are in range? Oh, it doesn't list the functions. I thought there might be like a distance or something like. Oops. Let's arrange. We have a start contains. We do have a len on a range. Let me comment all this stuff out so that I just want to see something here. Start equals 1, r.end equals 4000, println r.len. Oh, okay, so it does do this is an exclusive range. So I think there's a range inclusive. Which does not have a default apparently. Is there a new on it at least? The trait exact size. Oh, okay. So an inclusive range can't do a len, but an exclusive. Okay, so I don't know if it's helping. We just have to make sure that we add one. Oh yeah, I could just do that. You're right. But now we don't have len. If I do this, then we have len, but it's not enough. All right, so let's start off. I guess if we're doing it recursively, we don't have to worry about this. We can just say workflows get. Can I just do this? Or it's saying it's expecting a stir. No, it took it. Okay. And then let ranges equal how okay, so if we start off with 4 ranges of 1 to 4000, right? We want to call a function that says take this current workflow and process it to do all of this stuff. So we can say, I don't know, possibilities of itself, post, cur wf, and ranges. Right? And now we have to write the code that actually does the work. So let's quit out of that. Let's split this, and then up here we'll go to the top, and this will be the possibilities, which takes in the workflow, which is a vector of rules. And our current ranges, which is range 4. Can I do that? Will it let me do that? Let's find out. And it's going to return a usize 0. No, I need a generic argument like that. No, expected range usize. Right, I can fix that, but what's wrong here? Oh. Yeah. This is saying expected ampersand range usize, but fact. Oh. Fact range integer. Oh, okay. Do I have to actually tell it it's a usize? Nope. Oh, is it because I just did this instead? I should just do this. Oh, come on. Okay, it took that. Oh, okay. Scoop says no, don't put the semi 4 on there. Okay, let's try that. Yeah, okay. It's just that it has to be 4, right? Because it's XMAS. Okay. So now we're going to apply each rule in turn. If we have a rejection rule, right? So we're going to say for rule in rules. There's a reference to a rule. Match rule. Why won't it fill my match arms for me? I actually have to look up what my rules are now. Oh, right, rule condition. That's what we're matching. So for each rule, for each condition, if the condition is less than, what we're going to do is we're going to actually make a copy of the ranges here. So that we can change it. Var, val, var. If the condition is true, oh, right. And then we have to check to see if there's no pass fail thing, but we do need to check the action that we're going to be taking once we get there, right? Okay, so for less than, then we have to change, we have to create 2 different ranges, right? For less than range and the greater than range. And the less than range will then get passed to the action, and the greater than range will go to the next rule in the rule set. Ooh, okay. Scoop says it's probably going to be easier to just pass in the own value for ranges rather than a reference. If you pass a recursive function, it'll never need it again. Oh, I see what you're saying. Okay. I do want to be able to pass it in. Okay, then I guess I'm just going to generate a brand new one. Okay. Mohad said, just solved part 2. Yay, what part are you on? I am 80% of the way through part 2. 90% of the way through part 98% of the way through part 2. Okay, there we go. All right, let me take a look at my cheat sheet down here. Where is it? Here it is. So for less than, all right, we need to create 2 ranges, right? One for less than that will pass through to the next action, and one for greater than or equal to that will pass to the next rule. So I don't know what to call this. This would be a recursive call. Deeper ranges clone. And so deeper of var is going to get val -1, right? And then we're going to have rules of var is going to be equal to val. And then down in the action, and Scoop says here you can just declare ranges mute in your function definition and just modify it for the ranger to pass to the next rule. You're right. All right, let me just get this out of my brain first, this part of it. Match rule action, right? Actually, we can check action reject up above, right? Because if we're going to reject it, there's no point in doing any other work. If we're going to accept it, we still need to know this part. Okay, so accept is going to be, I guess we have a total for this. We're going to accept it. We're going to accept each one of the ranges in here. So it's not the value of it's the range len plus 1. So total plus equals ranges. Ranges dot iter dot map r len plus 1 sum usize. Now look good. This just does nothing, and then go to means we have to actually call with deeper workflow. So this becomes let wf equals workflow self workflow get workflow unwrap, and then we're going to just recursively call it with the deeper. This is unknown. Self pause wf deeper total plus equals. Oh, this has to not sum. This is product. Soup says you still need to do the work if R is in the middle of the workflow. Well, we're doing the work. We're rejecting the value here, but then we'll go back to the next rule. Oh well, right, and that should have the correct. Won't it? Right, because if reject is in the middle of the workflow, let's find one like that. Well, this one just says reject reject. This says reject accept. So if we come down here, let's say we're on PV. A is greater than 1716, right? And I haven't written the greater than one yet, but it's just the opposite of this thing, right? I'm doing it now, but oh, okay. Yeah, maybe I it's easy for me to misspeak while I'm in the middle of doing this, so. Is it prod or product? It still says no information available. Okay, if it's true, in other words, this always passes and we're always going to do the rule action, right? So I don't think we don't have to change the ranges here. Scoop says, be perfect all the time. I'll try. Oh, we can't clone ranges? Or we can't clone arrays? Oh, right, but that was the other thing. We could just hit mute on here. But I still need to make a copy of it. We can't clone for the deeper. Iter collect copied collect. No, that won't work. Oh, I forgot the colon there. Anyway. Right, I got to go back down to pos here and change this. Oh, yeah, so we do need that. This is iterating over the ranges. The ranges are these range of use sizes. I'm just trying to copy them. Oh, can I clone? Okay, maybe this will work. How do I do this? You think I can just clone the ranges now? Okay, let's try it. This is probably, I'm not returning the right value here. I got to put total at the bottom. Okay, there we go. And I probably can remove this part as well. Yes, okay. Do I need to, that's a U size, that's a U size. Oh, you know what I'm doing is deeper is a range, right? So I have to change the end here. And ranges var start, right? And we do the opposite here, start and end. Workflows, like that. Expected ranges for found. Oh yeah, this is the problem I had before, right? All right, let's just fix that. Comma. Almost there. Rule action. And now workflow is already a reference to a string. And we got a number. Do you want to try it? Do you want to try the number? It's a big number. This would be amazing if this worked first try, right? I should try it on the test code first. Let's just try it. Ah, too low. Okay. It's a big number. It looked correct, but all right. Let's test it on the test input. Input. There we go. Oh, that's right. I like to do this way so I can flip back and forth. So close. So close. All right. Yeah, it's off by a lot. Actually, this is higher, right? This is 167. This is saying 176. Yeah. So this one's ending up higher than the other one. My actual answer is ending up lower. So I'm guessing it's got to be in here, that I'm not trimming the ends correctly. Let me pull up my cheat sheet again. All right. So looking at this one, where we go to px, if s is less than 1351, I can actually print these ranges out, right, with the test input, and we should be able to see them all. There'll be a lot of them, but we'll be able to probably read it. So s, when we pass it to px, it should be 4,000, 4,000, 4,000, 1350, right? And then when we pass it to qqz, it should be 4,000, 4,000, 4,000, 1351 to 4,000, right? So we can at least test that. If we print out each one of these as we pass them to the different rule sets, right? So before we call self-pause, we can say println workflow, and what we're going to pass to it is just going to be deeper, right? So what we're passing to px is correct, right? 4,000, 4,000, 1350. Message says, ignoring the A and R actions, the workflows form a tree of depth 6. Yeah, I could put a little indentation thing in here. But here's QKQ. Oh. I thought QKQ, maybe this is the problem here, because I have a 2005 here. Oh. Is it on the wrong one? Because here's the 2005. QQZ, where's QQZ? A is less than 2006. XMA. No, that's right. That's right. I just got it wrong here. I got it wrong on my cheat sheet here. Okay. So this should be 4,000, right? And this should be 2005. And then we should have an accepted one. Oh, I should print that out as well. Did I do a thing here? I did. And by do a thing, I meant, did I make it debuggable? So let's do this. Print rule action is going to get the deeper thing. And that way we can see the full action. And then it accepts the 1415, 4000, 2005, 1350. Yeah, okay, that's right. And then we pop up and go to CRN. Right. So CRN should have an X of 1416, right? And it does. All right. So what am I missing? And I'm adding 1. I didn't forget to add 1 on the range lengths. Oh, should I be doing this on deeper? Yeah, because that's the values that we're doing. Oh, what a stupid bug. Okay, do we have it? 868. Thank you for spotting that, Scoops. I appreciate that. 868,000. Okay, all right. Very good. Very good. So all that's left to do now is to change the input. Right? We do have a number. It's higher. I think the other one was too low, right? Yay, that's the right answer. Okay. All right, that was a really fun one. That was a really fun one. And thank you to chat, everybody in chat, for all the help with this one. But yeah, this was one of the more fun ones. Let's get rid of this thing here. Don't need that anymore. We have 4 warnings. Oh, I think these warnings are from a different thing. And then we don't need to pass in a reference here on line 113. Oh, 133, sorry. And we can get rid of my cheat sheet. How's that? Still give us the same answer? Yeah, close enough. Okay. Yeah, this was a lot of fun. Part 1 was interesting because you just follow the rules, and then part 2 is interesting because you have to figure out how to trim the ranges. Very nice, very nice. All right.